All right, good morning, everybody. I think this is kind of a tutorial talk in its own little section here, so I'm honored to have been asked to give this talk and setting myself up here. Okay, thank you for coming. My name's Liz McDonald. I'm from NASA Goddard. For those of you who don't know me, if this is the first Steve talk you've been to this week, welcome. If this is like the 16th, I'm sorry, but thanks for coming as well. So this talk is about the stories of Steve that we all have, and also community and citizen science and disruptive innovation. So the inspiration for this talk is that we now have new technologies all across our society that can really help us engage and do science. And that actually changes access to science and enables authentic science learning through citizen science. And I believe that's changing space physics and astronomy. I put a new quote here from Dr. Thomas Buchan of NASA, that innovation moves at the speed of trust. And so this is kind of a new thing. We're learning about this. I've been working on citizen science for 7 years now, but we're still learning. In our field, it's still quite new. Okay, so citizen science across many different fields has a lot of disruptive innovation where you find something that you never would have possibly imagined, like a new species or all kinds of new things. And so in this case, Aurorasaurus is a project that can help us track the aurora in real time, which we really have very coarse methods of doing only, and no way to get those alerts out to the public. Not no way, but limited ways to get those alerts out to the public and to allow them to help participate in the project, in the process as well. So this enables new audiences to learn about our field, what it actually is, space physics and astronomy, and help us with a dearth of data that we have. This is the one slide on Aurorasaurus. I think most of the people here do know about Aurorasaurus. I want to, so this is a data fusion platform for the Aurora people's reports and tweets. We're now looking at incorporating other scientific sources of information and fusing all of this data together. I want to acknowledge my first postdoc on this project, Nathan Case, who's in the room, and some of his papers here, showing that people can track the boundaries of the aurora, and that can be helpful for improving our models of aurora as well. In our case, citizen science has a well-suited fit to the problem of where is the aurora and how can we improve our understanding of it. And the one point to make here is that we actually have a public, and we now know who they are, and we now have social media and ways to connect with them more broadly than we have in the past, particularly in the past solar maximums. Of course, we're now in minimum, but the last solar maximum was really the first with social media. And so that has changed our field. And how is it going to change our field for the next solar maximum? We also have more and more sensitive cameras and cell phones, and the ability to now carry around phones that can pick up photons that our eyes can't see, and make visible more of the invisible, typically invisible plasma processes happening above us. And this also feeds into education and getting the word out about space physics as well. So how many people here have heard all about Steve, don't know about Steve? New to Steve, a couple people, excellent. Okay, so this is a video taken by a photographer from Saskatchewan. His name is Natani Barasa. He took a very nice time-lapse video of a Steve event here. And the story of Steve, there's many stories of how we all met Steve, but I'm going to show a little video here that talks about, shows that nicely, that Goddard put together. Also recommend people look at Eric's TEDx talk about how he met Steve, and there's many other NASA features and actual news features all over the internet that you can find about Steve. Okay. People were out observing the aurora, and they started noticing something that was overhead as well when they were seeing the aurora far to the northern regions. It was unlike most aurora. Talked to the scientists, we didn't know what it was, and together they said, we'll keep taking observations, and we'll call it Steve in the meantime. Steve is mostly a very narrow purple arc, and sometimes it has these little green features that go along with it as well that are kind of like waving fingers or a picket fence. That means that there's plasma physics happening up there to cause that light and to make these little discrete features that we don't understand yet. We now have some satellite observations from the ESA satellite called SWARM that show that Steve optically is associated with a very strong flow in the particles in the ionosphere, the upper level of our atmosphere. Steve is important for a number of reasons. It's really exciting that people armed with cameras all over the globe can capture something that we didn't fully understand and shed new light on that. It's also really exciting that this happens further to the south where there are more people, so it might be a kind of aurora that more people can see than the usual kind. We're now able to look up at the sky and see things about the aurora and this subauroral region that we never understood before. And then we can correlate that with our traditional observations and lead to greater understanding. All right, thank you to the Goddard folks who put that together and properly edited things so you can actually see better. So to get into the science a little bit more, the first paper, modern paper on Steve, is this paper. Many of us in the room have contributed, definitely a team effort here. And so what we found is that citizen scientists were talking about something. It did not have a scientific definition, and we went after gathering more information. And so we found this very nice event in July of 2016, where there were observations from the ground from multiple citizen scientists. There were observations, an overpass of the SWARM satellite, the ESA SWARM satellite, with instruments built by the University of Calgary and European groups. And so proper measurements of what could be happening in this very narrow region. And what that showed is that these are the satellite observations on the right. And so the SWARM satellite was able to reveal that when you cut straight through this very narrow east to west lavender ribbon, it's a very strong flow east to west. There's very hot electrons, heated electrons, a strong peak of electrons, that's the second panel. And then also this is happening in a very low density region of the subauroral ionosphere. So basically the aurora is still far to the pole, and then there's a gap, and then there's this small narrow feature that satellites cut through, and it shows a strong bump, a strong flow. And actually, our satellites have been measuring this kind of feature for 40 years, and it's called a subauroral ion drift. However, it was never known to be visible. And so particularly strong subauroral ion drifts, where the speed is more than 5 kilometers per second or something like that, are actually visible. And so this is kind of significant. Professor Larry Lyons was quoted in The Atlantic that's kind of significant. That doesn't happen in our field very much, and was really impressed with this being discovered by citizen scientists, brought to us by citizen scientists, and working together to answer their questions, as well as this being a new structure in the aurora is quite new and interesting. So this is a little real-time video from Tasmania as well. So those of you who are space physicists, many have seen this type of video, but there's a lot of features here. The Steve is this lavender ribbon, and then the picket fence is actually moving here as well. And so there's been a lot more work going on with this, as well as a collection of citizen science observations from all over the world. So I will move on to some of those. So we know that citizen science lets us see differently. We can literally get more information on the Steve feature than you often can from satellites that cut through such things very quickly. And in some cases, because Steve is an unusual wavelength or spectra, it's more easily seen from people's cameras than from the array of scientific instruments, which also helped us piece all of this together. Okay, so moving on, there's definitely been a nice feedback loop with the citizen scientists and photographers, where many of them have, as this has gone viral like 3 times, at least 3 times, have been featured, and that's helped motivate citizen science in the public as well. There's also a broad spectrum of really authentic science learning and engagement happening. If any of you have kids, there's like 5 to 10-year-olds, there's a nice podcast called Wow in the World that did a super fun description of Steve. There is a junior high student whose science fair project is actually on something that many of us in the room are researching. There are students who are going back to school because they've back to school or in school, very motivated because they've taken and been taken by astrophotography as well. And there are also people for whom taking photographs of the aurora really is important to their life, and in many ways going way beyond science and what we do in this conference. Moving on here, some of the next frontiers in citizen science. These are some of the many faces of Steve from images from Mike Gear in Alberta, Canada. There's a lot to explain here. And one of the next frontiers that I talked about a couple days ago has been put together by a man named Michael Hunnicle. And he is not the photographer, but he is an amateur aurora historian and a physicist from Germany, and he has put together an extensive database of both historical and modern public media and citizen science observations of Steve that can help the scientific community and be used together. And so this is really exciting. This increases the number of events that we've been able to find, and really is a great new resource. And also he's found new features in looking at all of these, all of this data. What you can see here is the great vast increase of Steve observations since social media and the last solar cycle peak and the media picking up this story. So there are many more observations here recently, as well as his database goes back 20 years, and then he has a more historical database as well. There are pieces of this we're still looking into for sure, and this is not an absolute rate, but geographically, perhaps Steve is distributed differently around the world. Maybe it likes Alberta for geophysical reasons especially. And then also, Steve is difficult to predict. It can be seen during larger storms and also during quiet times. And we haven't, as far as I know yet, figured out how to predict Steve. Couple more points here brought forward by Michael and his look at many different images. So he noticed many of the first images were taken with longer exposures, and so Steve was like photobombing the Milky Way in a nice long exposure Milky Way photo. But shorter exposure time also can reveal new features and be kind of a new frontier for challenges to the citizen scientist. In the Steve arc here, perhaps revealing some taller rays as well in the main Steve arc. Michael has also come up with a triangulation method. This is different than triangulation in the past because you have a network of people that are not coordinated, and their camera clocks might not be coordinated. But you can track those features and put them together. Bill Archer recently did related similar triangulation, and that is published. Michael has come up with similar heights and picket fence velocities as well. And this is good to try different methods of triangulation, figure out how we can best make this happen with these people all over the place. They kind of have to be in the right place to get the heights of different features. And this could be a great project for students or enthusiasts to continue on and get better at tracking the height of specific features from Aurora. This was actually done a long time ago. And now, also thanks to Michael, we have unearthed previous observations of Steve from the early 1900s. And it's somewhat reassuring. Steve Mendy actually said this to me at the meeting that, oh, I'm actually kind of glad Steve's been seen before. But these publications are quite obscure now. And there's a man named Carl Stormer who was a pioneer of auroral photography, had a network across Norway, took 12,000 photographs and carefully triangulated the height and classified a whole bunch of different types of aurora. And on 7 dates, he saw Steve, and he has published papers on these. He notably called what we now call, Steve, feeble homogeneous arcs of great altitude. And he also noted the atypical spectra. So Michael has, I think I neglected to mention this, Michael has put his lists on the Open Science framework where they are citable, and I would encourage people to check that out and talk to him. This is actually a picture of Carl Stormer. It's a pose picture, and an assistant and what they did back in the day. So it's tremendous work. They took 40 years of observations. We can now go back and read these publications about the techniques and look at these as well. So actually we have an upcoming commentary on this topic. And now I want to transition a bit to some modern Aurora citizen science pioneers. So who are the modern versions of folks? Because most of the scientists in the room here do not go out and field instruments like this anymore and watch the Aurora for 40 years like this. But it's done differently now, but citizen scientists can actually contribute as well. And so very recently, we have some citizen scientists in an extreme citizen science expedition in Svalbard, Norway. They are way up north, 77 degrees north, and they are not observing Steve because they're too far north. But they're in a place, they're up there for 9 months. They're observing dark cusp aurora, which is exceedingly rare. That's the kind of aurora that directly happens from the solar wind impact in the atmosphere. There are many questions about that kind of aurora and the way reconnection works and the sunward and tailward sides of the magnetosphere. This is a topic for an upcoming NASA mission called Tracers. But anyway, they're out there and they're doing citizen science and raising awareness of climate change. They have a really extraordinary expedition. And I met them and have introduced them to Aurorasaurus and also introduced them to the fact that There are also some crazy space physicists up in Norway launching rockets above the cusp aurora, which is a thing that we do. And that's a way to get a lot of information about the features and the dynamic plasma physics happening up there. Differently, cheaper than satellites, and useful as well. So they were like, yeah, we'll go out and watch when the rocket is launched and take additional observations. And that's really important in this case because this type of rocket is actually not just looking at cusp aurora, but looking at artificial aurora. And so this is a very low resolution iridium thumbnail that they sent to me just yesterday because this rocket just launched 2 days ago. But they did get, I have confirmation that they got images of the artificial aurora, and then we'll look and see if those are helpful to enhance science from the additional sites that also measured this kind of artificial aurora. And they were really dedicated to do this. It was, along with the rest of the team, they got text updates and they were just waiting for several days. This was a thumbnail from Thanksgiving, so that's 3 days after this rocket launch window opened. And they're delighted to be doing this, possibly more delighted than the scientists who've been up there for 5 weeks at this point. And so a couple more thoughts. Citizen scientists as stakeholders. So they aren't just the end goal, and they are definitely not just assets to our science. Their time is a valuable resource. Co-creating projects and topics of interest with them leads to higher impact. That's been shown in the citizen science field. The folks in this picture, on the left, Hannah, she is a citizen scientist from the UK who started as a photographer and has gone now to become an Aurora guide. She's gone to a European Space Week social on Aurora, and even gotten so motivated she looked up a MOOC, a massive online open course on space physics and plasma physics, and was like, I'll listen to this and I'll learn more. So she presented a talk at European Space Weather Week just a month ago, as well as Michael, who is here, whose work you saw earlier. He presented 2 posters, and then he also had a poster here that I presented. But this was really great to have citizen scientists actually at our meetings, and particularly in space weather and auroras, having outside views, I think is very helpful to us. And then this is also Jordan, who's the young woman that had the science fair project. And as well, this was at a documentary called Chasing Steve that the story has just gone viral and been loved by many people across the world, especially Canada. You guys have a coin, and filmmakers from Victoria made this film with funding from TELUS, the Canadian telecom company. So, okay, but really what does successful citizen science need to have? This is a very good paper by Andrea Wiggins that suggests the science products inventory. Citizen science is not easy, and it's not just talking to these people. There are best practices for data practices to make the data findable, accessible, interoperable, reusable, and to publish your products and communicate your findings back to the citizen scientists. Also to potentially have policy impacts. That's something that our project, one of the collaborators, Michael Cook, has recently done a master's thesis on possible impacts of citizen science to space weather policy. If we have really large storms, how can we include the public, and how can that help us? Okay, coming back to Steve and the science, because that's what we're all here for at AGU. These were some mostly open Steve questions from about a year ago, and I am pleased to report many of you in the room have made tremendous strides on some of these questions. Megan Gillies has recently published a paper showing the spectra of Steve. Bill Archer has published a paper showing altitudes of these features. All of this is really critical to help better explain the crazy plasma physics happening here. Michael is working on a number of these questions. Bea is working on a number of these questions and has published a number of results. A couple of people have started to find conjunctions between Steve events and our satellites way out in space, hundreds of thousands of miles away, and to really understand what's happening along the magnetic field lines that are dynamically moving during these events. And so there's a number of questions that are being actively worked, and this is really exciting. So if you want more Steve, there are a couple of posters this afternoon. There are a couple of talks tomorrow morning, 10 o'clock. And I might have missed a few, I apologize. But check out those sessions, and that's really exciting. There are more future opportunities with Aurorasaurus. I'm looking for a postdoc if anyone knows anyone who would like to work on this. We also have a collaboration with data assimilation for geospace. That's a new project by Tomoko Matsuo of the University of Colorado. There's an opportunity if anyone is in an EPSCoR state, especially if you're a computer science type of person and want to work with us, because all of this data has a lot of utility for computer science as well. There's a NASA opportunity for that. And there's a NASA request for information on interdisciplinary gaps. Maybe people have can put in responses to that about citizen science. That would be great. Nathaniel Fursell, who's in the back, has a new DAISY project on the Personal Space Weather Station and an upcoming meeting with ham radio scientists, Aurora scientists, and citizen scientists. That's going to be awesome. We are reinvigorating our ambassador network to work with folks. That's led by Laura Brandt, my new project manager at Goddard, and at NASA as well. They have now basically said citizen science is real science and you definitely should do it where appropriate. So you can talk to me about how that's happening in terms of policy for heliophysics, or Mark Kuchner, who's here, is heading that up for all of SMD. And finally, thank you very much to many folks, everybody. Thanks. Okay, I have a couple of minutes for questions. Any questions? Mom?
When are you going to take your mom and dad to see Aurora?
Yeah, we'll work on that. Thanks. Anybody else? All right. Yeah, Nathaniel.
Do you give recommendations to the Aurora watchers as to what equipment to use or how to set it up?
We have not. They have their own groups, and they do tend to give camera advice within those groups. Like the Alberta Aurora Chasers is really phenomenally welcoming and has notes on cameras and equipment. We have not done a lot of training of that part of it because it is also so broad. Vincent, who's a student at University of North Dakota and an Aurora Chaser, is interested in making, kind of infographics and more along those lines. So maybe you guys can talk if you have some ideas for that as well. Bill.
Just sort of adding to that discussion, there's certainly been a lot of interest from the community in being directed. And they want to know, what sort of observations do you guys need? What can we do? How can we help? And so far, the answer that I have been reliably giving is just do what you're doing,
Yeah.
Is it correct in my understanding that one of the reasons Steve was found in the citizen science is because the professional instrumentation was so narrow-banded or looking for very specific wavelengths that it missed?
Yeah, the way that we take scientific observations is very different than people going out and exposing for beauty. And so the differences helped find Steve. However, we are definitely, have done, not direct the community, but request the community input in certain ways. We've had a Steve week, it was like years ago, but when this was first starting to gather observations, and as Michael is pointing out, now pushing towards the lowest exposures could be really interesting and something to point towards. I'll go with Eric.
I just always want to make a quick comment on that, first of all, as a community, I think the Aurora chasers know more about photographing and capturing images of the night sky than we do as a community. And so I think I now look to them for help from them as opposed to the other way around. And I just would make one point, which is Steve is very visible in our camera data. We just were studying other things, right? And it's in retrospect, it's almost sad that we missed it, right? Because it was, I had seen it myself and dismissed it, or thought I'll go back to it later. I took a photograph of Steve on a street in Calgary, posted it on Facebook, and said, "Wow, Aurora over Calgary," right? And like, so it's very visible in our data.
It's really interesting. I think it's been lost and found over several centuries, if that makes you feel better. Brian, did you want to say something?
Building on that, there is a paper by Sarah Jones in 2006 or 2009 with geograms of Themis ASI, and you can clearly see Steve in Athabasca station. But of course, she didn't comment on that because we didn't know it was different. So that's really interesting.
Yeah, there's a lot that this is what I'm trying to say. Citizen science, and it's, we have our own bias, and we have many sessions on substorms and all kinds of stuff, and the subauraural region particularly. And also, I kind of feel like the northern boundary probably also has some cool stuff that might be not well known yet. But we are definitely going to have to check Stormer also. Final question, Brian.
So I was just going to ask about the observations. If we have some ideas for like observations that would help,
Mm-hmm.
would we just post on Facebook or run it by you guys? Or?
So I would love to help broadcast those through the Aurorasaurus community, which is tied in with multiple other communities. Yeah, but it can go all ways. Yeah.
Have like a community front?
Yeah, that's what, yeah. And, doing the social media and all the things. But we that's why we actually have ambassadors with the different regional groups. And some of the groups we have not had that much good contact with because it really also takes a face-to-face kind of thing. So we are looking forward to building more connections with other regional groups as well. Yeah, thanks so much, everyone.